I'm Glenn. My day job is running the tech part of a small low-tech startup. And usually when people present, they have a slide where they say, oh, this is all the stuff I've done. I'm not going to do that. I'm just going to say I've fallen flat on my face so many times. I made so many horrible mistakes. My only redeeming point is I haven't made the same mistakes twice because I learn from mistakes. Because failure is a cruel but effective teacher. But I built a lot of systems over the years, and doing that I learned and discovered a few things that I'm hoping I can transmit to you. I'm going to talk about some of the things I've found to work very well, which is events. The title kind of spoils it, but shouldn't really be a surprise. So I'm going to talk about how events are, and I'm going to talk a little bit about how they fix some of the problems I've had throughout the years. This talk is in two parts. We're going to talk first about the what and the why and the what. Why do we want events? What are they? More than just events. And then we're going to talk a little bit and show a little bit about how you do it. And I'm going to use some examples using what's called Azure Event Grid, which is a service in Azure. I'm using that because that's what I know best. The concepts and the way of thinking about it are universal. They will be the same if you're using event systems on any public cloud and several on-premises systems. We good with that? Excellent. So, two terms first, which you'll have to define, because I'm going to use these and make sure everyone understands it. Cohesion, the action or fact of forming a united whole. Basically, what we're saying is that things that belong together should be together. So, when you have an application that is, everything is scattered all over the place, you have low cohesion. In order to do anything, you have to go here and do something, and then you have to go here and do something, and that relates to that, which is over here, and that relates to this other thing, which is over here. Then you have low cohesion. It is generally regarded as a bad thing. Because if you can't find what you're doing, or the next part of what you're working on, then it's going to be hard to work on your system. The other one is coupling. Connecting parts of machinery, or how different connections between the parts in your systems. And we'll often talk about loose couplings and hard couplings. Hard couplings is when this part cannot work without this part. Then they have a hard coupling. And they're mentioned by name. You need both these things in order for the first one to manage. For instance, our UI can be hardly coupled or hard coupled to a service. And can be hard coupled all the way down to the actual database we're using. Or it can be loosely coupled where we have a service depends on something that looks like this. And if you attended any solid talks, you know that dependency injection and abstractions will help us replace whatever looks like this. Then you have loose couplings. In general, couplings should be low. And you can define your boundaries where you want to keep low couplings, and you can have, okay, these parts can have high couplings, but they should have low couplings to other parts. So what do we do when we make a new system? Well, often we go file new, or we feel really elite, and we do it from the command line. And we make a project, we start making the foundation for the application we're building, unless you're building a completely trivial application. But any non-trivial application will start with you building a foundation to build upon. Problem is, when you're starting out, anyone here consider themselves doing agile work? Working in an agile fashion? Okay. The rest of you work in a rigid fashion? Yeah. I'm using agile with small a, not capital A, like these. the prescribed Agile. But with Agile, which is considered a good way of making software, we're often taught that we should not make a huge design up front because we don't know what's coming down the road. So the foundation you're making is built to support this, and you're soon building this. But your foundation doesn't support it, and things just grow here and there. The weird thing about software and software architect, or building software as opposed to building physical stuff, is that no one builds a bridge and then someone goes, I bet we could land an airplane on that bridge. But people do those things with software. You make something and then someone comes, oh, we can use that for this other thing that nobody thought about. Oh, we want to add this other thing that nobody thought about before. Okay, we'll add this and add that. And over time, complexity in a working system will increase because you're adding more parts. So what do? Well, we try to decrease the complexity every now and again by doing craftsmanship, people call it, or doing proper software engineering. We split things up, we try to get a low coupling, high cohesion. The problem with this graph is that it's false. Complexity is not a linear thing, it's an exponential thing. Because as you add things, it doesn't just add one coupling and another thing and one coupling and another thing. You add something and it's coupled to 5 things. And then you add another thing, which again coupled to 5 other things and pulls with it another 5 things, and it grows like that. And your complexity reducing measures help for a while. And this, pretty soon you're left with this. This is real, actually. This is a class diagram. But it's not just software, it's also people. If you have a significant large project, then you'll have different teams with different agendas, with different requirements, different release schedules, maybe even different languages. So what do? Well, with these complexity reducing measures, a powerful thing is start dividing your application into different parts. It may be different parts in the same application, which is a good thing, or it may be different parts in different services, which is a more complex thing, but it will still give you huge benefits. So we find the elements with high cohesion, and we say, okay, you guys over here, you guys over here, these fellows over here. And these things can scale independently. The mistake that people do is that they forget about the couplings. So now we have this service, which talks to this service, this service, this service, and that service. And this other service needs those 3 services. And any request has to go at least 5 different services. And you've made yourself what's called a distributed monolith, which is a huge application just sliced in weird ways and placed on the network. And you've made things worse. And whoever was here in the previous talk, I bet Jimmy had a couple of words to say about that. So what we want to do is decrease the couplings. The common way of talking between services is via some kind of HTTP interface. I send some kind of message, some work gets done, and I get an answer back. And this works fine until service B is gone or unavailable for some reason. What happens here? Then I have to introduce a bunch of logic here to make sure that this works out. A has no idea how long B is going to be away. This is a problem. And then you multiply this by 5, 10, 20, and it's a huge problem. The problem here is that A has to have a lot of knowledge about the rest of the system. He needs to know what other services are there, where are they, what are they called, how do I reach them, what do I do if it fails, and so on. We need to remove this need for knowledge and reduce the hard couplings. And we do this using events. So what are events? How do they work? Well, in essence, they're small messages that an application or a service or part of an application can put out somewhere. So I can have a part of this, could be a separate service, it could be just a part in a large application, it doesn't really matter. But it is a thing that is defined as a thing. It puts out a message saying so-and-so. It could say something like, customer registered. And that's it. That's all it does. It doesn't care what happens next, in general. And we have a different service, which listens for events. So when service A here goes, hey, so-and-so just happened, service B goes, oh, I'm interested in so-and-so happening. I'm going to get a look at that. We'll get in on that action. And it will pick up that message, and it can do whatever you want with it. And then it can have more of these. These are called subscribers. They subscribe to messages. So whenever a message appears, all subscribers get a copy of that message. And here's the beautiful part. None of these have any knowledge about any of the others. They do not know they exist. There is zero coupling between these four services or parts. They have zero knowledge. Now, here's the beautiful part, or the cheating part. There's a part in the middle here, which is our event processor. This is our message service. This is the thing that receives the message from this guy, the publisher. It will publish a message onto the service, and the service keeps track of who wants that kind of message. This whole system is asynchronous, meaning that when this puts out a message, it gets back from message servers, it's okay, I got this. And it's done. It has no idea what happens next, in general. There's always edge cases and there's always special cases, but in general, the way we're talking about it, this has no idea what happens next. Especially at least in this context. There can still be failures. So if one of these services are gone, the message service has all the logic and all the capabilities it needs to retry the message. So they're put in, and it knows that these three services should each get a copy. And if they're not picking it up, or they're not delivering it, or they're not processing it properly, then it will keep trying. Eventually, if it's gone for a very long time, it will eventually fail, but we can pick that up as well. There's something called a dead letter queue, where all undeliverable message that timed out will be delivered. So what happens if the messaging system is down? Well, it can happen. It's not that likely because you often put a lot of work into making sure it's not down. And in our case, we're using a cloud service, which has phenomenal uptime historically. But it's a problem that you need to handle here, but that's one problem for one service, and that's it. So it's a lot less complicated problem. So what's a message? Message consists of an envelope. Yes, that's a technical term. A message envelope, which has a bunch of data on where does this message go. And it usually has a topic. So a topic is a destination for the message. So the publisher will send a message to a topic, and then subscribers will subscribe to a topic. For instance, we can have a topic called customer. So any messages related to customer can go to that topic. Or we can have more narrow topics, which is customer update or customer created. It doesn't matter, it depends on what you want. But the topic is sort of the delivery point, the mailbox that it goes into. It will also have a timestamp. It will have a type. So we have different message types going to the same topic. And when I subscribe, I can filter on those. The same thing that happens when you come home, you open your mailbox, a bunch of mail, ads, bills. This one goes to you, this one goes to you, this one goes to me. Oh, this is one I'm interested in. So we can filter, subscribers can filter on type. So we subscribe to a topic and we filter on type. And every message also has an ID. So say this whole system was asynchronous. The sender has no idea what happens. Well, what if it wants a reply? What if it wants to know something back? Well, we can, inside the envelope, that's our data. We can there specify the return address as you would in a letter. If you're writing a letter to someone, here's some information, and at the bottom, please reply to, and here's my address. So then we basically have two topics. So we send a message, it gets processed, and in the message is the return address, and it will send a reply back through a different topic, which this service on the left is subscribing to. Now there's no free lunch. Setting up an asynchronous system requires you to change the way you think about your system. You can't just take an existing application and just toss some events over and paint some events with lipstick on it and you're done. You have to re-architect your system to react, to work in an asynchronous fashion. That is the hard part. It's not really hard, but it's a mind shift. Especially when I don't know what happens yet. Like, I'm doing this, but things are happening, I have no idea what happens. And in order to think about an event-based system, we have to define the difference between messages and events. Those are two different things. I've used the word a little bit interchangeably, but they actually have a meaning to them. The difference is in the intent of the publisher, the service putting out the message. So I'm a service and I'm putting out a message, and if I have an expectation of what should happen when I put this message out, that I want some data to be created, I want a record to be changed, I want a workflow to be started, I want something to happen, then it's a message. Having an intent of getting a reply back will also make it a message. So a message is something of value. It could be, I want money to be moved from this account to this account. And I need you to tell me when it's done. In a message is always high-value data. So if the message was lost, it would be a bad thing. You would be sad, and the service would be sad because things wouldn't work. And people who wanted to move money from one account to another would also be sad, especially the ones with the receiving account. If the message is lost in transit, then the value is lost. This is different from the situation where the publisher has no expectation of something happening. It's putting out a message to inform, often about a fact or something that happened. Customer created. Customer created is an event. Create customer is a message. At least if I expect the customer to be created. When someone is putting out an event, they have no expectations of something happening or even someone listening. They don't know, it's just, this thing happened. I'm good with that. That doesn't mean that you won't be sad if this message is lost or the event is lost. The system as a whole might suffer for it, but the service that is putting out the event doesn't care. So it's not that they are without value, but the service that is putting out the event, for that service, it is without value. We also separate events in two categories. Discrete events, they're about actions carried out by the publisher or stuff like that. And then we have data points or stream events, which are a continuous stream or continuous log of data. So you can have sensors, IoT sensors, temperature sensors in this room probably, that will send out events. The temperature is so-and-so, the temperature is so-and-so, temperature increased, temperature decreased. Is a stream of data where we're not interested in the actual event, we're interested in the trends over time. So if you have an application that lets the world know that a customer was created, it has no expectation of what should happen. This is an event. It can be picked up by one service that adds the customer to newsletter. So on the left here, we have some UI where someone registered as a customer, they put it in, it got stored in the customer got stored in the database, persisted somewhere, and then it's pushed out, customer created. We have created a customer. We can have one service that checks, is the customer eligible for promotion we're currently running? Maybe that's a temporary service that is created and lives only for this promotion. It's a 2-week thing. Every new customer gets sent some new welcome package. And so we make a little service that does exactly that and nothing else. That means I can introduce new functionality to my system without touching existing parts of my system. So when a business analyst comes to you and says, oh, by the way, when a customer is created, can we do these things? Because there's a new campaign we're planning to do, and you can go, yes, I can do that, and there's no problem. Then we have another service that creates a logging, updates some reporting. It doesn't really matter. And the main customer service here is completely unaware that this stuff just happened. Has no idea. And if those 3 services disappeared, it would do his work just as well. So those are the concepts. Any questions on the concept so far? No one putting in on Slido, you can do that as well. So, in Azure, we have 3 different systems for dealing with events and messages. Service Bus, Event Grid, and Event Hub. They all have specialties and use cases. Event Hub is a streaming event service where it will ingest a huge number of events, and it will take those events, handle them, push them out, store them. People, subscribers can subscribe to a point in time, they can go back and forth, they can look at the data stream over time. It is not for business events, it is for streaming data. Event Grid is a service built for discrete business events. It is built to handle stuff like customer created. You create topics, you subscribe to topics, and you publish the topics. And you can add filtering and stuff like that. And the nice thing about this one, which is a bit different from others, it is a push system. I'll come back to how that works. And then you have Service Bus, which is the OG messaging service in Azure. Service Bus is also the basis of both Event Grid and Event Hub. They are special cases of Service Bus. But Service Bus will do a bunch more mission-critical stuff. It will have transactions. It will do queues. It will do relays across firewalls and all kinds of stuff like that. It's much more enterprisey. Clients are expected to connect to the Service Bus, and they're expected to pull messages out of the queue or topic. So let's look at Event Grid. So one of the advantages of Event Grid is that it has a number of pre-built integrations to it. So there are several services in Azure which have a built-in Event Grid publisher. Stuff like storage blobs, IoT Hub, media services, and a whole bunch more that didn't fit on here. And there's also a bunch of Azure services that have built-in consumers, including lodging apps and Flow, which are very non-code tools, but also functions, if you want to go serverless. And we're going to take a look at webhooks, which is a mechanism for getting stuff out of Event Grid. So let's see if this works. Yay, it does. So let's we can zoom that a little bit more, I guess. There. Right. So Event Grid is a service. You don't create an Event Grid instance in Azure. You create subscriptions or topics. So the Event Grid is just there. There is no scale unit on Event Grid. There is no use service of a specific size. It is a background service, completely oblivious. You do not manage it at all. It's a completely managed service. All you say is that I want to push events somewhere, and I want to receive events somewhere. So, oh, that was not the one I wanted. Let's go with this one. There's a tool called Azure Event Grid Viewer, which is a little thing that Microsoft put out that you can deploy to your own Azure instance, which can subscribe to events. You can send it events, and it will just display the events here. I'm going to use that a little bit for the demos. So, how do we set up a subscription? I'm going to set up a subscription from a storage container, saying that when something happens on my storage container, which is just storage, blob storage in Azure, similar to S3 if you use the Amazon, when I put files there, I want an event to happen. You can do this from the console. You can do to automate it, or you can use the portal. I prefer using the console. But since you probably don't feel like watching me type as much, I'm gonna cheat. And cheat significantly. So I have AC is the command line interface to Azure, AC Event Grid, event subscription, create. I have a source resource ID which says pick events from this source. And storage ID is basically the path to my storage. It's a long path, so I just put it in a variable. I need a name for my subscription called blobs, and an endpoint, which is the URL to post the events to. Let's put this here, and we'll put this here. So when I'm now telling Azure to, oh, shit. Oh. Double dash, there we go. So now I told Azure, start an event, and something happened here. I got a subscription validation event. Ooh. Up, please. So whenever I start a subscription, I get a validation event saying that you need to validate that you actually want these messages. So your endpoint needs to confirm that, yes, please send me messages. Please send me events. And what it gets a validation code, and it needs to return that. Otherwise, Event Grid won't start sending you systems, messages. So we'll put that there. Now, let's see. what I get back from my command was a bunch of data, including the destination. Oh. The destination of where these things go. It's the endpoint. It's BS Event Viewer, Azure Websites.NET API Updates. That's the address of my event service. And it says include these event types, blob created and blob deleted. Those are the types. And then there's the ID of the actual subscription that I want to, the actual Event Grid subscription. And there's my topic, which is the point or the actual storage account that I'm getting events from. So if I now do AC storage, let's upload a blob. So this is just a command for taking a file and upload it to storage. So if I do that, oh, there it is, blob created. So now my blob's created. And here's my event envelope. It has a topic, has a subject, event type, event time ID, and has a data point. This is the contents of my event. The content will vary depending on your event type. In this case, it's a storage event. So it'll have the URL to your blob. It will have what happened to it, I was put there, which API stuff, and all that. Now, that's all nice. But let's make our own events. Or let's make our own subscribers. We'll start with that. So here's some code for subscribing to events. This is a normal plain ASP.NET website. There's nothing special about it, except it has a controller. I've called it update. It has an action called status, and it takes an event grid event array from the body. So I can post an array of event grid events to this service. And here's what we have to do. We have to make sure that, is this a subscription validation event? Then we have to extract the validation code and reply with a validation response. This is to make sure that our service will actually accept the messages. And then we can do whatever we want with other messages. I'm not doing anything here, I'm just logging it to the console, but here is where you would process the event and do whatever you want to do with it. So let's run the subscriber. So let's create another subscription. Let's call this one blobs2. And my endpoint is https billstuff.eu.ngrok.io. ngrok is a service that will make a tunnel into my computer. So I have ngrok running in the background here, saying that if you put something on this address, then it will be sent to my localhost port 5001. So it's a way I can test event grid subscriptions and stuff like that from my local machine, but still going through the cloud. So the cloud can send messages down to my machine. And this I have to do because the event grid is a push-based system. Many other event-based systems, you create a subscriber and it will connect to the system, it will keep a connection open and pull stuff in. But Event Grid will push stuff to you, which makes this very suitable or useful in serverless systems which are not running all the time, especially combined with a webhook. So let's set up a subscription to go to my, yeah. It's going to have a problem with that because I forgot the actual URL. Okay, let's do it from this one instead. /update/status. That's what we want. Unless this one, no, still not done. Okay, let's send it there. Now, hopefully, there we go. So now I logged 2 messages. I got received an event type with type Microsoft Event Grid subscription validation event, and I validated the subscription with the validation code. So now I'm hooked up. So now my service is running. My event grid has verified subscription, and I can start pushing events to it. So if I upload another file, so here's my event grid viewer. Shove that over there. Take this and shove over here. And so upload this file, and I get one event here, blob created, and I get another event here at the same time. So here's my event, put data, client request ID, all the stuff that I needed, build stuff to PNG, and on here, same thing, build stuff to PNG, same image. These 2 apps are doing the same thing. They just got a webhook set up, and they're both receiving the events. If they are unavailable, now the subscription is set up, the events will be retried every hour, and it will be retried for 24 hours, and then it will put in a dead letter queue. If I've configured that, I can choose not to do it, or I can choose to do it or not do it. Right. So let's publish events. The thing about Event Grid is that it's completely HTTP based. There's no proprietary client. It has the event format is by default on a Microsoft Event Grid format, but you can also tell it to use a cloud events standard instead, which is a common standard that can be used in many different systems. But let's. So I have a status event. It's just a string on my command line. So let's take it up. So let's take that string and put it into HTTP, which is a little Python command line application for doing HTTP on the command line. Post this message to a topic endpoint, which is just a URL for the event grid. I'll show you that afterwards. Application JSON, and it needs a key. The event grid has a key in order for you to push message to it. Otherwise, anyone could put messages into your system, and you don't really want that. No, I haven't set that up yet. We need to Azure Event Grid topic create. Let's take one that's called status. Cool. Even grid as opposed to the odd grid. Oh, forgot the name variable. There you go. So now I'm creating a topic with, so the previous command, when I connect it to the Azure storage service, it's a shortcut. It will create the topic and will create hook up a publisher and do all that for you. Now I'm creating just a topic. I'm going to cheat a little bit here. No, not that one. Topic key. Oh. So what I'm doing now, the Azure Commandline, it extracts, it connects to the topic, and it extracts the key one and puts it in a variable, so I can use that from my command line. So now I can post status events from but there's no fun in posting something without setting up a subscription to it. So let's do Azure Event Grid, event subscription. Actually, let me put it on top so the people in the back can read it. So Azure Event Grid event subscription create, topic status, which is the topic I created. The name of the subscription, status, it could be anything, it's just the name for the actual subscription, so I can have multiple subscriptions to the same topic. Endpoint, BSEUN, grok.io, update status, send it to the same endpoint. So now I'm setting up the subscription, take these events, push it here, it's validated, which is nice. And there I got the Azure, all of that back. So now I take my status event, I can post it to the endpoint and include the key, and if everything works. So that gave me OK straight away. And down at the bottom here, event data, status also. Probably a lie, but whatever. So how do we publish from our own program? Well, same thing. I'm going to need that key. So the key and the host name is just the endpoint which I'm working on. The event grid endpoint. Status, West Europe 1 event grid azure.net. There's an SDK for this, so I can just say a new event grid event. Put some data on there. Status right now is, I don't know, what event time? Subject can be anything I want. I'll just use that to put up for my information. In this case, it's Thursday, we're in room beta, and a data version for my event. So I can version my event, so I can filter based on versioning. So if I have multiple subscribers, I can say, I want event version 1.0, I want event version 1.2, for instance. Create some credentials, new up a client, and then publish events async to the host name, which is defined right over here, and just publish a list of events. So I can publish multiple events at the same time. So if we go back here, I'll go into publisher, because that's the way Visual Studio wants it. .NET Run. It will crash horribly. The request authorization key is not authorized. Okay, maybe my go to the publisher again. Maybe I had the wrong host name. No, same one. And my topic key. Something wrong here? No, it looks the same. Maybe I didn't save. See if this works. Well, it's taking its time. Anyway. No. Okay, I don't know where that event went. So, some questions that came up since we're running out of time. Why Event Hub is not suitable for business messages? It is, totally, but it's business messages that we want to do something after the fact. So we're using it we're making a bunch of contracts, for instance. When someone is submitting a form, we publish events, and based on that, we will be logged what happened, we will create PDFs and all kinds of stuff like that. Event Hub versus Kafka, pros and cons. Kafka is more like Event, not like Event Grid, but like Event Hub. Event Hub is a managed service. You just subscribe to it and you don't care. Kafka is usually not. Kafka can persist data indefinitely if you want to. Event Hub cannot do that, so it has retention. Apart from that, it's like, Event Hub can pretend to be a Kafka server if you want. When to use Event Grid and when to use Service Bus. Service Bus is more for when you have high-value, mission-critical messages that must be delivered when they take part in transactions. Maybe you have queues and you have services that pull one-on-one message. Those are Service Bus cases. You want to cross the firewall, Service Bus. What is advantages using this Azure service instead of RabbitMQ or Kafka? Excluding the support we get from using cloud service. Pardon? High availability. So the thing is, there's a whole bunch of problems you don't have to care about. That's why I use the Service Bus. Or that's why I use the cloud. Actually, let's drop into, maybe I'll see if I can find that here. Oh, there we have. So, I posted this on Twitter. Servers are a problem. Of course, PowerPoint needs to fix my thing. I posted, servers are a problem, want someone else to care deeply about. And then this guy replied, Clemens Vasters, who owns messaging in Azure. He's the chief architect of everything to do in Azure with messaging. So I was pretty pleased with that. The reason for using a cloud service like this is because there's a whole bunch of problems I don't have to care about. High availability, scaling, making sure it just runs. I don't care. If I put up a RabbitMQ, then I've got a pet. I have to take care of that pet, and the pet pees on my carpet every now and again. Apart from that, pretty much the same. They do the same things. It's just I don't have to care about a whole bunch of things. Push versus pull pattern, when to use. You have to pull if you're behind a firewall. So any cases where the managed service cannot directly communicate with you, then you probably have to pull. Push, especially in serverless configurations. I mentioned logic apps, where you can publish events for your system and you can have non-coders connect to your events and do stuff on their own, basically making flowcharts. I can show you that out in a break if you want. Any advice to go about versioning with events? Property and bodies might change. Keeping backward compatibility can cause a lot of clutter. You can use the data versioning field to phase out events, so you can create new versions of your events with a new data version, and you can filter on data version on the subscribers. So anyone subscribing to 1.0 events can keep doing that. Anyone subscribing to 1.2 events can keep doing that. You can also make sure your events are backward compatible by adding stuff and not removing stuff. There's basically just JSON. So depending on how you connect with them, you can shimmy that about as you please. Was that? And I think I've gone 2 minutes over time, so that was it. If anyone want to get in touch with me, hook me up on Twitter. I'm at, there we go. I'll go to the front instead. Hope you're on Twitter at Henriksen. If you want to chat with me about it, I'll be here for the rest of the week. And yeah, and use the BuildStuffLT hashtag, and I'll probably check in that as well. So thank you. Oh, by the way, sorry. Don't forget to put a green card or something, or the color if you want, especially want to do that in the outside to evaluate. People who run the conference appreciate that. Thank you.